Hi, and welcome to video number 31, or 31, 32, sorry about that, 32. As we see here, we're going to be talking about angular velocity, angular acceleration, angular distance, how they're related to distance, velocity, and acceleration, and also angular momentum. So here we have angular, or we're going to say distance, which is represented as x, is equal to theta times r, where r is the radius. Here, velocity is equal to the angular velocity times r. Acceleration is equal to the angular acceleration times r. So now we have those out of the way. Let's look at angular momentum. So as we know, normal momentum is equal to mv. But in angular momentum, we also have to consider r. So we have to multiply it all by r. But here we already run into a problem. As we see, what if you are only given an angular an angular velocity, but you need to solve for momentum? So in this case, you can actually plug angular velocity times r into the v. So now we have So, angular momentum would be equal to m times angular velocity times r squared. So, let's see how this can be used to solve a problem. Let's solve problem number 32. So here it says you have an orbiting particle so with radius r, and we want to find the angular momentum of the particle or about the center of the circle as a function over time. So basically we know in the word problem we are actually given the particle has a mass of m, radius of r as shown here, and then the angular speed of the particle is given by the function where b is a positive constant and t has to be equal to or greater than 0. So now that we have this, we want to find out the angular momentum, and we know the angular momentum is equal to m times v times r, and if you remember the relationship between velocity and angular velocity, velocity is equal to angular velocity times r. So let's plug that in right there. And as you see here, we are given b and then t, right? B and then t, and then we're going to plug this in here. So and then we also have t. I just moved that over to here. So then our final angular momentum would be m times the angular velocity times r squared, and all that times t, because we want it as a function over time. I forgot about b. There's actually a b here too. So that would be m. Oh, right, the b. So we replace this with here, but it's actually a b. So this would be b, mb r squared times t, since bt is a function of angular momentum, or of angular velocity. So our final answer is over here, which is answer C.